Okay, dear student, to implement the third experiment, which is DC motor drive using single-phase controlled bridge rectifier in Matlab Simulink, first of all I'm going to go to Simulink and open blank model. Then this blank model I'm going to go to library. So the circuit shown here is going to be connected. So I need AC voltage source. I'm going to go back to library and write AC voltage source. You can just say AC volt and bring this one. You need to make sure the black one, not the blue one. And what else I need? Also I need thyristors. So I'm gonna take this thyristor and send it back to the model or the new model. So this is the AC voltage source. How many thyristors I need? I need 4 actually. I'm gonna rotate them and duplicate or make them 4 actually. Connect them as a bridge this way. And the positive part of the AC voltage source is gonna be here. The negative is gonna be here. As long as I have inductive load, what I need also freewheeling diode. So I'm gonna write diode. I'll take this one, rotate it, so it will be working as a freewheeling diode. So as long as I'm going to control the speed of a DC motor, so I'm going to take DC machine. I'll use this one. And the DC machine requires DC voltage source. I'm gonna go to library, say DC voltage or just DC volt. I'll take this one. This one also is supposed to be rotated, so the positive will be on the positive of the field, the negative on the negative of the field. I'll connect the positive of the armature to the upper side of the converter or rectifier, and the negative to the lower side. What else I need? I need also a constant, so I'm gonna write constant, take this one and connect it to the DC machine. So this is gonna be the torque or the load torque. I should make it 10 and positive, which means that the DC machine is going to work as a DC motor. What else I need? Actually, I need a pulse generator for these thyristors. So I'm gonna write pulse generator, and as long as I have 4, so 1 pulse generator to this and to this thyristor, the diagonal, and the second pulse generator is going to be for this one, the second maybe, if you number them 1, 2, 3, 4, so for the second and the fourth. Okay, what else I need? Actually, I need a power GUI to make this to make this circuit work. So the power GUI, and to see the speed I need a bus selector. So I will connect it first here and pick the speed from the list. So I'm gonna pick this one and delete these 2 signals. Also what I need a display to display the speed. If you would like to see the waveform, you need voltage measurement. So I'm gonna write voltage measurement, connect it here to the freewheeling diode or the output of the rectifier. And we need oscilloscope or scope to see the waveform. What else we need to set the parameters. So the AC voltage source, I need to set the voltage to 240, same as we have in Iraq, and 50% the hertz or the frequency. I need to set the DC machine to the model number 1, which has 300 volt as a field, and we need to set this to 300 volt. And what else we need to set the pulse generator. So first of all, as we have 50 hertz, so the period is supposed to be 1 divided by 50, which is 0.02. Okay, so this is going to be for the first one, for the second one as well, 0.02. Now let's suppose that the phase delay for this converter or rectifier is 0. So it's going to be 0 here for the first pulse generator, and here it's supposed to be pi or 180, which is in seconds going to be 0.01, or the period divided by 2. This period divided by 2, so it's going to be 0.01. So now I set the phase delay for 0, or the alpha for 0. Now I'm going to run the circuit and see what I have. You see here I have the speed radian per second 122, and to make sure that your circuit is working well, that you need to see the waveform here, and from the shape of the waveform from 0 to 0.02 you will see that this is a correct full wave output form. But now if you want to go further and change the alpha, maybe you can change the alpha or the phase delay here. You can set this, change this 0 to 0.005 and run the circuit again. Then you will see that the speed, as long as we are increasing the phase delay, so the voltage is going to decrease, the speed also is going to decrease. And to make sure that we are or our circuit is implemented in the right way, so we will see that here we have this from 0 to 90, 0, and after that the waveform is working well. So this is the implementation of the circuit of the experiment number 3.